Connor, thank you very much for that introduction. I hear that there are over 1,300 participants in this XLab event participating virtually. That is a great that's a great turnout. That is way beyond any of the other events that we've done in the past. Obviously, there's advantages to being virtual, and wider audience participation is among them. We were going to do this in New York City, up and top in the building, where only 200 people were going to be invited, and we were somewhat struggling before the changes and challenges of how we were going to only try to pick 200 people. So I do think that this is an excellent venue for breadth, and I'd like to thank Brookhaven National Lab for leading this and setting this up. It's obviously got broad exposure. I'd also like to thank Connor as Chief Commercialization Officer for the National Lab Complex and his office for setting this up. This is a particularly exciting day, just to talk a little bit about the broad sciences for us at the National Lab Complex. Just yesterday, the Nobel Prize for Physics, in part, was supported by the Keck telescope that we support and Lawrence Livermore supports. And today, the Nobel Prize in Chemistry was to Jennifer Doudna, who discovered gene editing, which is vitally critical to many aspects of where we're going in life sciences, and in the short term, helping to develop therapeutics and vaccines for COVID in a year versus years. So we would like to congratulate them. And the other thing I would point out today, and I think will be discussed later, is OSTP at the White House publishing the Quantum Frontier Report, which is a very long layout on a new website called quantum.gov, which you all can take a look at. If this is your first XLab, I'd like to take a minute to discuss the impetus of these meetings. The Department of Energy invests more than $18 billion a year in various research in the national lab system across energy and the sciences and many other areas. And one of the things that we saw as a leadership team when we came in was that we didn't have a lack of content at the National Lab Complex, but we certainly could improve upon a good history, but we could improve upon the making connections between the content that we're developing at the National Labs on various topics and bringing it forward to entrepreneurs in the private sector to try to build collaboration and try to push along the application of technologies. And so that two-way communication is really the thesis of the XLab series. We've had a number of these that have happened. The first one was on energy storage. The second one was on grid technologies. The third on advanced manufacturing. Then one on artificial intelligence. And the last one on biomanufacturing at Lawrence Berkeley. And we have another one coming up on carbon capture. So the outcomes of those various different events that we've been doing for the last few years have been very impactful. There have been hundreds of follow-on conversations and various agreements between national labs and the private sector companies on helping move forward collaboration, research, and licensing of technology that we've helped develop. So I think as I overall mentioned about quantum, I think as many of you know, our leadership team in this administration has been very active and aggressive in the promise of quantum technologies. Since the National Quantum Initiative Act that was passed in 2018, DOE, as well as the National Science Foundation and the National Institutes of Standards, NIST, have been very busy executing. The passage of that bill had a great impact. I think we're seeing that with the participants for this meeting. I'd like to thank again the Congress, the House Science Committee, and the Senate Energy Committee for passing the bill and for funding everything that we're doing right now. It has been an amazing outgrowth, and I'd like to thank them again for their leadership. Earlier this last summer, in July, earlier this year, just a couple months ago, we rolled out the National Lab Blueprint for the Quantum Internet. We did that at the University of Chicago. And obviously us having conducted a workshop, last workshop I attended before COVID issues at the beginning of February, mapped out with the top 50 experts in the country on how to develop the hardware and software stack for quantum networks and ultimately a quantum internet. and then how to actually go about building those networks. So if you haven't seen that, that's something that we published for the country here a couple of months ago, and it's online. Also, just a few weeks ago, we also announced the awards for the National Quantum Initiative Centers for up to $625 million in support of sustained and coordinated development of quantum science and technologies, and for the establishment of the quantum workforce. Each one of these 5 quantum centers incorporates a collaborative research team spanning multiple scientific and engineering disciplines and multiple institutions. And each one will work seamlessly to connect with the private sector, both existing partners and hopefully other people who want to engage with them to connect. Those awards were met by an additional $300 million in contributions from the private sector and universities and states. And so in totality, we announced just under $1 billion. And if you think about it from a venture capital point of view, we just funded $1 billion in pre-venture capital technologies. And if you stop and think about it that way, a typical seed round, however big typical seed round you want to call it, $1 million, $2 million, we just funded $1 billion in the area of basically a series of seed round investments. So that is extremely material. We also had 69 entities participate in the 5 centers. So one of the main things that we wanted to do was to help create a community, as well as developing specific technologies and drive science. So the breadth of the participation was very key in our decision making, and hopefully we're making a difference. We have everyone from national labs to major universities all over the country, including historically black colleges that are participating. And we have the major private sector, and that was a major criteria for this, is to have private sector participation in the centers. So we have IBM, Applied Materials, Rigetti, and many others. And we've invited 2 other countries into our national project in quantum. So Italy and Canada are part of those, and we're certainly open to other countries joining in the national project associated with quantum. And so just in the last few months, we've had a number of already successes and things moving down the road, even though we just announced it, the various centers. So let me give you a little bit of a snapshot of what we've just started accomplishing just in the last few months. At the center led by Fermilab, they were in the process of setting up the first high priority experiments. And one in particular is working with Rigetti Computing, providing dozens of characterized qubits for material studies. At the center led by Oak Ridge, we're working on a number of areas dealing with topological insulator devices and topological qubits to grow topological insulating crystals for characterization. In addition, our Office of Technology Transitions, so our tech transfer group led by Connor, has been collaborating with NASA already to explore the opportunities for the DOE national labs and the centers to leverage their satellite assets for quantum networking. And we've initiated a series of discussions with NASA's Goddard Space Center and PNNL, Pacific Northwest Lab. And we already have interest from General Dynamic Mission Systems and Sky Quantum around the satellite topic. Also at Sandia National Labs, we're working on trapped ion processors developed by the scientists there to be made available to scientists to explore the power of computation using trapped ions. And we're also working with QECD, which is a great network set up by the Commerce Department, which is, I think, very key to help coordinate with the private sector on a number of these moving technologies and coordinating for whether it would make sense to develop additional test beds for industry to test existing quantum technologies in sensing, networking, and computing. And then the last thing that I would mention, it was already mentioned about Doone Gibbs and the network that we have. The Secretary mentioned that on Long Island. We also have the Quantum Loop in Chicago, where we're testing a metropolitan scale quantum communication test bed with Oregon, the University of Chicago, and Fermilab and many others around the Chicago area. So I'm very excited about, finally, just to wrap up, of the participants who are in this, just to hit on one of the panel areas. From quantum computing area, we have Dario Gil, the head of IBM Research. We had John Martinez, formerly of Google, and obviously very well known for what has occurred in the not so distant past in computing there. We have Jeremy O'Brien from PsiQuantum. We have Chad Rigetti. Just in the narrow topic of computing, I appreciate really leaders in this in the world that are participating in this conference to talk about how we can try to collaborate more, and certainly the American taxpayer dollars going into the national lab system, and try to help build a community, help build workforce, and hopefully develop technologies that can help the private sector deploy and to drive this industry. So Connor, many thanks for that, and thank you again for setting this up, as well as Brookhaven.